Hi guys, back with me again, Adi Kurniawan Yusuf, and in this video we're gonna talk about one sample hypothesis testing. What is the difference between one sample hypothesis testing and two samples hypothesis testing? One sample hypothesis testing, we would like to compare a sample data with a specified value. For example, is the average test score higher than last year's average score? Known that last year's average score is 70. It means we want to compare the average test score with 70, whether it is higher or not. While for two sample hypothesis testing, we would like to compare two sets of data or samples. For example, is the average test score of male students is lower than that of female students? We want to compare the average test score between male students and female students. This is two samples hypothesis testing. In this video, we will focus more on one sample hypothesis testing. And in the other video, we're gonna talk about two samples hypothesis testing. Just as the reminder for you guys, these are the steps to conduct hypothesis testing. There are 6 steps. The first one is that state the null and alternate hypothesis. The second one, determine the significance level or alpha. The third one, select the appropriate test statistic. The fourth one, formulate the decision rule, determine the critical value and also the region in the graph. The fifth one is taking the samples and do relevant calculation. And the last one, make conclusion. To learn more about hypothesis testing, you can watch previous video. To conduct one sample hypothesis testing, there are two common tests. The first one is C-test, the second one is T-test. C-test is used when we have large sample size. The sample is more than 30 and the population standard deviation is known. So you have met these two requirements, large sample size and population standard deviation is known. This is the formula to find C calculation. The X bar is the average of the sample, mu is the mean of the population, small sigma or tau, it is the population standard deviation, and n is the number of sample. If one of the requirements I mentioned previously doesn't meet, we have to use T-test. So T-test is used when the sample size is small, less than 30, or if population standard deviation is unknown. The formula of T-test is almost the same with the C-test. The T equals to X bar, it is the average of the sample. Mu is the mean of the population. S is standard deviation of the sample. And n is the number of sample. In T-test, we also know about degree of freedom. Degree of freedom equals to n minus 1. And here is the number of sample. So, degree of freedom in one sample hypothesis testing will be equal to number of sample minus 1. Let's discuss directly the first sample question. Heinz, a manufacturer of ketchup, used a particular machine to dispense 16 ounces of its ketchup into containers. From many years of experience with the particular dispensing machine, Heinz knows the amount of product in each container follows a normal distribution with a mean of 16 ounces and a standard deviation of 0.15 ounce. A sample of 50 containers filled last hour refilled, the mean amount per container was 16.017 ounce. Does this evidence suggest that the mean amount dispensed is different from 16 ounce? Use the 0.05 significance level. Based on this question, we can recall that the population mean is 16. So mu equals to 16. And then, stated here, a standard deviation of 0.15 ounce. This is the population standard deviation. because it is stated that Haynes knows the amount of product in each container follows a normal distribution with a mean of 16 ounce and a standard deviation of 0.15 ounce. This is the population data. So the population standard deviation or small sigma or tau is 0.15. The number of sample is 50, and then the mean of the sample is 16.017. The alpha or significance level is 0.05. The first step is that we determine the hypothesis. We need to see the question. The question is like this. Does this evidence suggest that the mean amount dispensed is different from 16 ounce? The question here states 16 ounce. Yes, 16 ounce the population mean. And the keyword here is different. If the keyword is different, so we use not equal as the hypothesis. You have to watch again the hypothesis testing video if you forget about the concept. Is not equal will be put in the H1 or alternate hypothesis. So the H1, mu is not equal to 16. It is put in the H1 since it doesn't contain equality. While for the HO, it will be the opposite of H1. So the mean equal to 16. The second step is determine the significance level. The significance level stated is 5% or 0.05. The third step is select test statistic. Since we have population standard deviation and the number of sample is more than 30, so we can use Z-test. One more time, since the population standard deviation is known and the number of sample is more than 30, we use Z-test. In this test, we will use two-tailed test because our hypothesis is equal and is not equal. The fourth step will be formulate the decision rule. This is the drawing of the graph. Since the significance level is 5% and it is two-tailed, so the significance level will be divided by 2. 2.5% and 2.5%. 2.5% in the right and 2.5% in the left. In this picture, it represents the blue area and it is the rejection area. While for the white area, it is do not reject area. To find the C critical, we can see it from the C table. But we have to find first the half area of the bell curve outside the shaded area. The half area will be 50%, the shaded area 2.5%, it means the white area will be 47.5% or 0.475. Then we can directly find it in the C table. If the area is 0.475, we can find the C will be 1.96. Since it is two-tailed, so we put 1.96 in the right, and in the left, we put minus 1.96. Is it clear, right? This is the C critical. So the C criticals are minus 1.96 and 1.96. We also can find the C critical using Microsoft Excel. Okay, so this is the way how to calculate the C critical using Microsoft Excel. In this case, we use two-tailed test, but I will give you information how to find the C critical for both one-tailed test and two-tailed test. If it is one-tailed test, again, if it is one-tailed test, the formula will be like this, equals norm.s.env, open bracket, the significance level, close bracket. The C critical will be minus 1.64485. If it is one-tailed in the right, just change the negative number into positive. It means 1.64485. However, this test is two-tailed test. Okay, so the formula will be the same, equals to norm.s.env, open bracket. the probability divided by 2. Okay, the probability divided by 2, close bracket. You can find minus 1.95996. Since it is two-tailed, it means there will be 2 C critical. The second C critical just convert the negative value into positive value. I can say equals minus this. Or I can also use the same formula, norm.s.env, not directly probability divided by 2, but 1 minus probability divided by 2. It is 1.95996. If I round it into 2 decimals, it will be the same, minus 1.96 and 1.96. After we find the C critical, we can set the decision rule. If the C calculation lies in the blue area, it means we have to reject HO and accept H1. If the C calculation lies in the white area, we do not reject HO. In other words, I can say if the C calculation falls between minus 1.96 and 1.96, do not reject HO. If C calculation is not between minus 1.96 and 1.96, we should reject HO and accept H1. Now we go to the fifth step, make the calculation. The C formula will be x bar minus mu divided by population standard deviation over square root of n. It will be 16.017 minus 16 divided by 0.15 divided by the square root of 50. It equals to 0.801. This is the last step, making the conclusion. Since 0.801 or the C calculation falls in the white area, so we do not reject HO. Again, in the statistic, you cannot say accept HO, but you can only say do not reject HO. And then you make the conclusion in the words based on the question. I can say that the mean amount dispensed is not different from 16 ounce using 0.05 significant level. You can say not different. You cannot say is equal. Cannot. You have to say is not different. Or you can also say we cannot suggest that the mean amount dispensed is different from 16 ounce using 0.05 significance level. Now, how if the question asks you to find the p-value? What is p-value? When you use SPSS or you use Microsoft Excel, you can easily find the p-value. But through this video, I would like to give you the concept how to calculate the p-value. P-value is basically a smaller area from the edge of the bell curve to the certain value. In this case, is calculated value. For the C value, using the C table, you can exactly find the p-value. But for the T value or T statistic, using the T table, you can only find the range of the p-value. You cannot find the exact value of the p-value. In this case, we have found that the C calculation is 0.80. If I see from the C table, if the C is 0.80, then I can find that the area is 0.2881. 0.2881 is the half of white area. So let's focus on the half of the bell curve only. If the white area is 0.2881, it means the blue area will be 50% minus 28.81%. It will be 21.19%. But don't forget, it is two tails, so there will be two blue areas. If the right blue area is 21.19%, the left blue area will be the same. So the total p-value will be 2 times 21.19%. it equals to 42.38%. Using this p-value, actually you can set the decision and also conclusion. If the p-value is more than alpha or the significance level, do not reject its O. If the p-value is less than alpha, reject its O and accept its 1. In this case, the p-value is higher than alpha, right? The alpha is only 5%, while the p-value is 42.38%. So, do not reject its O. The conclusion is the same with our previous conclusion. Now we go to the second sample question. If previously we used z-test, in this question we will use t-test. A machine is set to fill a small bottle with 9 grams of medicine. A sample of 8 bottles revealed the following amounts or grams in each bottle. The data is given. At the 0.01 significance level, can we conclude that the mean weight is less than 9 grams? The population standard deviation is unknown. The number of sample is less than 30, so we use t-test. We know the population mean is 9 grams. To know population mean, actually you can also see from the last question. The mean weight is less than 9 grams. Usually it is population mean. The n will be 8. Since we will use t-test, we can also find the degree of freedom. Degree of freedom will be n minus 1. So 8 minus 1, it equals to 7. The alpha or significance level will be 0.01. The data is given, and since we will use t-test, we have to find the x bar and s. X bar is the average of the sample or the mean of the sample, and S is the sample standard deviation. To make it easier, we can find it using Microsoft Excel. To calculate the average, we just use the average function. So equals average, and we input the data, enter. And we found that the average is 8.8. For sample standard deviation, we just input the function of sample standard deviation. It is equal stdev.s, and then open bracket, the data, close bracket. We can find that the sample standard deviation is 0.226779, or we can round it up into 0.227. Using the Microsoft Excel, we can find that the x bar is 8.8 and the s will be 0.227. Now let's go to the first step, determining the hypothesis. The question is, can we conclude that the mean weight is less than 9 grams? Less than. Less than should be put in the H1, since it doesn't contain any equality. So the H1 will be mu is less than 9. The HO will be the opposite of H1. Mu is larger than or equal to 9. The significance level will be 1%. Alpha equals to 1%. The third step, select the task statistics. Since the population standard deviation is unknown, in addition, the sample size is less than 30, so we use t-test. But in this t-test, we use one-tail test, since the HO and H1 is higher than or equal and also less than. In addition, since the H1 is less than, the task will be one-tail test in the left. Now we go to the fourth step, formulating the decision rule. This is the graph. We know, right, that the F is 7 and the alpha is 1%. So we can find directly in the T table if the DF equals to 7 and the alpha is 1%. Remember, if it is one-tail test, you don't need to divide the significance level with 2. But if it is two tails, you need to divide the significance level or the alpha with 2. We can find here that the T critical is 2.998. But since it is in the left side, don't forget to put negative signs. It will be minus 2.998. Based on the graph, we can see here If the t calculation is less than minus 2.998, it will lie in the rejection area. So we have to reject HO and accept H1. But if the t calculation is more than minus 2.998, we should not reject HO. For the t critical, we can also use Microsoft Excel to find the t critical. This is how to calculate t critical using Microsoft Excel. You have to understand the significance level and also the DF. In this case, the significance level is 1% and DF is 7. Again, in the question, we use one-tail test in the left, but I will teach you how to calculate t critical using Microsoft Excel, both for one-tail test and two-tail test. Let's find first for one-tail test. Equals to t.inv. If it is one-tail test, using t.inv. If it is two-tail test, later on you use t.inv.2t. Open bracket, the probability is 1%, semicolon, the DF 7. Close bracket. You can find the t critical will be minus 2.99795. If it is one tail in the right, just convert it into positive. It becomes 2.99795. If it is two tail, we use equals t.inv.2t, open bracket, the probability directly, no need to divide with 2, semicolon, the DF. You can find that the t critical will be 3.499483. Since it is two tails, so there will be two critical value, one positive, one negative. For the negative one, just convert it into negative, it becomes minus 3.499483. But in this question, since it is one tail negative, we use this value. The fifth step is making the calculation. We have had all the data needed. The formula will be t equals to x bar minus mu divided by s divided by square root of n. It will be 8.8 minus 9 divided by the s 0.227 divided by square root of 8. The result of t calculation will be minus 2.492. Next step is make the conclusion. You can see here that the t calculation lies in the white area, or it is more than minus 2.998. So we should not reject it all. We can say that the mean weight is not less than 9 grams using 0.01 significance level. Or in other words, we also can say we cannot conclude that the mean weight is less than 9 grams using 0.01 significance level. Now, how to find the p-value? Again, p-value is the smaller area from the edge of the bell curve into the calculated value. In this case, the t calculation is minus 2.492 and the df is 7. This is one tail test. And in one tail test with df equals to 7, 2.492 is located between 1% and 2.5%. The 1% is 2.998 and 2.5% is 2.365. Therefore, the p-value is located between 1% and 2.5%. Is it clear, right?